everyone, my name is Elena Ashton and I am the co-founder of Education Empowers, a nonprofit which promotes STEM, robotics, and sustainability. I'm also the captain of my high school robotics team as well as the chief science officer and STEM ambassador of my school. In the second lesson, we will cover how to program your own race car. For Lesson 2, Speed Racers or Race Car, we have a few objectives. So the first one is to obviously build and program a race car or speed racer. This will also just help children learn to ask questions and also build their confidence with programming. We want to connect STEM to real-world problems and experiences. We also want to help kids to familiarize with the basic EV3 programming, as well as learn just to use different methods to measure the distance and move the robot around, do left and right turns, loops, etc. We also want them to have fun competing with each other. So the Speed Racers route, we usually tend to make a track out of sticky tapes or just regular duct tape. This can be either on a table, a floor, anywhere in the classroom really, or in any setting. This will be where the students will demonstrate their robots and program around the court and trying to maneuver the robot around the track. So there's also instructions to build a speed racer or a speed bot on the Lego website. So if your team has not already built a bot, they can come here and make their own bot. But usually we make the track out of tape, like I said, so that way the kids have something to visualize the distance they need for the robot to program. So the Speed Racers Challenge as an overview. So we're going to be using a couple of new blocks for this challenge. So you're going to build your program with move steering blocks or move tank blocks. There's also going to be different ways to move the robot. We're going to learn this lesson, which is to measure the number of rotations on the challenge route. How many rotations does the robot wheels have to make to go from point A to point B? Or we can just measure the distance and divide by the circumference of the wheels to get the number of rotations. But then there's also the question that you can use time in seconds to decide how much distance you need your robot to move. We'll be working as a team for this challenge, so programming hints are on the next page. We'll save and download your program and test it, and we will try and stay within the course. The team that competes and completes the course in the shortest time wins. So this adds a bit of a more fun aspect to the challenge itself. Now I've opened up my Mindstorm programming app, so I'm going to just go over here to this plus sign and add a new project. So we're going to just come over here and close content editor, that way we have more room for our programming. So for this program, the objective is to just have the robot go across the track, but we want the robot more specifically to go forward, turn, and then go forward again to do a more clear and precise section of the track. So we're going to get started programming. So first you want to note the start line and the finish line on your track, so that way you can measure the race course distances from A to B, from B to C to D, and D to A. So this will be more important when you program your robot, because you're going to actually have to decipher the actual distance of your track for your robot to be more precise and not go outside the track. So for when we program our robots, we have to use only pretty much just two basic blocks, which is going to be the move steering and the large motor. From the first lesson, we used a lot of the move steering, but however, I believe the large motor will be a new block for all of you to learn. So first, we're going to do a move steering block, which is the third block in, and connect it to our start block. So this is just to move forward from, say, point A to B on the track. I'm probably just going to put, say, 3 for my number of rotations, because I do have a small track here in front of me, so I'm going to try and be as precise as possible. Of course, there can be also, like we said, different methods that you can use. You can measure the distance from point A to B, and divided by the circumference of the wheel to get your exact number of rotations that you need. You can also just guess with the robot, move the robot across the track, or you can use time. So there's different methods for everyone to use, and obviously not everyone does the same method, but I usually just like to measure the distance and then divide by the circumference of the wheel. So that way my move forward is more precise. The next block we're going to do is we're actually going to use the new block, which is a large motor block. It should be the second one in the green section, and you're going to just click and drag it up. So this block is basically just to have more of a precise turn, which is left or right. The most important thing about this block though is the ports, because you have to make sure that the block is more specifically wired to the same ports that you're using for your move steering. So the main difference between these two blocks is with the move steering, this is basically telling both the motors that are individually powering your wheels to move at the same time, which is why it's B plus C. So both motors are moving. But for the large motor block, it's only one of the motors are actually being ran. So only one of the wheels are actually running. This is kind of helping make a more precise turn when you're doing a track, because now only one of the wheels will be turning and you're not going to have such weird angles if you were to do another move steering block. So now we're just going to make sure that we change the port. So I'm going to make a right turn or a left turn for my track, and so I'm going to go to port B and use this as saying that this wheel is going to turn to make a left turn for my track. So now we want the robot to move forward, so we're just going to go back to the move steering block, which is the third one in, and just click and drag it up. And so now after turning, our robot will move, say, another 3 rotations forward. So that way you have a clear and precise section of the actual track done. So to do the whole track, a lot of kids have different methods. Now we're just going to save our program. So we're going to go to File, Save Project As. So I will just label my program as Speed Racer. And just click Save. Okay, so now we're going to just download our program onto a robot. So after we save our program, we're going to download the program onto the robot, so that way we can run it. So I've already placed the download card into the USB, but I have to place it into the robot. So as you can see on the robot, there is a little section called PC, which is where the other end of the download cord is actually going to attach to. And once you plug it in, you should hear a little noise from the computer, but sometimes your computer doesn't make a little noise. So after we plug it in to the robot, we are going to click on the download button, and a noise should also come from your robot saying that it's fully downloaded onto the robot. So after you hear that noise, you can just unplug the download cord and you can search for the program on the robot. So I like to go onto the project section, so I just click once to the right, and you can see a ton of different files with different names. So what you saved your project as should appear onto here. So I'm just going to click the file, and underneath you should see a program. So I'm going to just go down and click Programs. So now for our lesson 2 speed racers or race cars, I made a little track which is just to represent an actual race car's track. So we're going to start from here and we're going to actually end over there. So I'm going to just press play, and if you can see, the robot is able to follow the track like a race car would. I hope you guys all had an enjoyable time programming your own race car or speed racer, and we can't wait to see you for the next lesson.